The lorikeet does not enter a landscape quietly. It arrives in flashes of color, bursts of sound, and rapid motion that instantly disrupt stillness. Where many birds rely on camouflage or silence, the lorikeet survives through visibility. Bright plumage, sharp calls, and restless movement define its presence. In forests where competition is constant and resources bloom briefly, subtlety offers no advantage. Evolution shaped the lorikeet around a single, demanding specialization, nectar. While most parrots rely on seeds and hard foods, lorikeets move toward a liquid-based diet that required speed, memory, and precision. Flowers do not wait. They bloom, offer resources briefly, and fade. To survive on nectar, a bird must track change in real time. The lorikeet's anatomy reflects this choice completely. Its tongue is not smooth like that of seed-eating parrots, but tipped with fine, brush-like papillae. This structure allows it to collect nectar and pollen efficiently, turning each feeding visit into both nourishment and ecological service. As the bird feeds, pollen clings to feathers and beak, carried onward to the next flower. Pollination becomes a byproduct of survival. Flight is rapid and direct. Wings are built for quick acceleration rather than long-distance gliding. The lorikeet moves between trees, blossoms, and feeding sites with urgency. Energy intake is frequent, but energy expenditure is constant. Nectar provides quick fuel, but little storage. This forces continuous activity. Stillness, for a lorikeet, is temporary. Color plays multiple roles. Bright plumage signals species identity within dense, noisy flocks. It may also function as a form of confidence display, reducing hesitation during aggressive social interactions. In a world where resources are limited and competition intense, hesitation can mean loss. Social structure is central to lorikeet survival. These birds rarely operate alone. Flocks form around feeding sites, erupting into motion as flowers are depleted. Vocalizations are constant, layered, and loud. Calls serve not only communication but coordination. Movement through forest canopies requires awareness of others at all times. Aggression is common but rarely lethal. Lorikeets argue over access to food, perches, and mates, yet these conflicts resolve quickly. Energy is too valuable to waste on prolonged confrontation. Dominance is temporary and situational, shifting as resources move. Habitat defines behavior. Lorikeets favor forests rich in flowering trees, but they are not bound strictly to untouched environments. Urban parks, gardens, and cultivated landscapes increasingly provide alternative feeding grounds. This adaptability brings both opportunity and risk. The lorikeet's intelligence is often underestimated because of its chaotic behavior. Yet beneath the noise lies complex decision-making. These birds remember flowering cycles, track productive trees across large areas, and adjust movement patterns accordingly. Memory, not strength, determines success. Despite their abundance in some regions, lorikeets remain vulnerable to ecological disruption. Changes in flowering patterns caused by climate instability directly affect food availability. Loss of native trees reduces reliable nectar sources. Competition with introduced species further compresses feeding windows. Still, the lorikeet persists. It does not wait for environments to stabilize. It moves, adapts, and exploits opportunity wherever color blooms. In doing so, it becomes one of the most dynamic expressions of avian life in tropical and subtropical ecosystems. For the lorikeet, feeding is not an occasional activity but a continuous state. Nectar provides rapid energy but demands constant intake. This metabolic reality drives nearly every behavior. The bird cannot afford long periods of rest. It must remain alert, mobile, and responsive to changes in food availability throughout the day. Flowering trees become temporary centers of gravity. When a tree blooms, it draws birds from surrounding areas. Lorikeets arrive quickly, often in large numbers, creating dense, noisy clusters of activity. The abundance is brief. Nectar levels drop rapidly, and competition intensifies. As flowers empty, flocks fragment and move on, scanning for the next opportunity. This constant movement requires advanced spatial memory. Lorikeets track not only the location of flowering trees but also their timing. Different species bloom at different intervals. Success depends on recognizing patterns and returning at precise moments. Mistiming means wasted energy. Social interactions at feeding sites are complex. Dominance is fluid and situational. A bird that controls access in one moment may be displaced the next as conditions change. Vocal signals communicate intent, status, and agitation. Physical contact is common but rarely escalates into injury. Speed and persistence matter more than strength. Nesting behavior contrasts sharply with feeding chaos. When breeding season arrives, lorikeets shift focus inward. Tree hollows become critical resources. Suitable cavities are limited, and competition extends beyond the species. Possums, other parrots, and birds compete for the same sites. Securing a hollow requires vigilance and defense. Once a nest site is established, activity becomes more structured. The female lays a small clutch of eggs, and both parents share incubation and feeding duties. Despite their energetic lifestyle, lorikeets demonstrate precise coordination during breeding. Feeding trips are timed. Returns are efficient. The chaos of flock life gives way to partnership. Chicks grow quickly, fueled by regurgitated nectar mixed with pollen and soft plant matter. This diet provides rapid energy but requires frequent feeding. Parents increase foraging intensity, often traveling farther to meet demand. During this period, adults are especially sensitive to disruption. Urban environments increasingly intersect with lorikeet life cycles. In cities, ornamental flowering plants provide reliable nectar sources. Artificial structures offer nesting cavities. These conditions can support large populations, sometimes leading to conflict with humans due to noise and property damage. Adaptation to urban life demonstrates behavioral flexibility. Lorikeets adjust feeding schedules to human activity patterns. They exploit gardens, parks, and even artificial feeders. This success, however, creates dependence on non-native plants that may not provide consistent nutrition year-round. Health issues arise when diets shift too far from natural nectar sources. Processed sugars and inappropriate foods lead to nutritional imbalance. The very adaptability that allows lorikeets to thrive near humans can undermine long-term health. Predation remains a constant pressure. Raptors, snakes, and introduced predators exploit moments of inattention. Bright coloration does not provide camouflage. Instead, survival depends on awareness and group vigilance. Alarm calls ripple through flocks instantly, triggering rapid dispersal. Climate variability introduces new uncertainty. Changes in rainfall and temperature alter flowering cycles, breaking the patterns lorikeets rely on. When blooms fail or shift unpredictably, birds must travel farther and compete more intensely. Despite these challenges, lorikeets continue to function as essential pollinators. Their movement transfers pollen across wide areas, supporting plant reproduction and genetic diversity. In this role, the bird becomes a connector within ecosystems, linking isolated trees through repeated visits. The lorikeet does not slow down to adjust to change. It accelerates. It expands its range, explores new feeding grounds, and reshapes its routines. Feed is not just movement, it is strategy. As young lorikeets develop, the environment around them becomes a classroom defined by urgency. Learning happens fast or not at all. Chicks emerge into a world where hesitation costs energy and missed opportunities cannot be recovered. From the earliest days outside the nest, movement is constant and observation is survival. Juveniles remain close to adults, absorbing patterns through repetition rather than instruction. They watch how older birds approach flowers, how they position their bodies to access nectar efficiently, and how they respond instantly to competition. Skill is acquired through proximity and trial, not guidance. Flight proficiency develops rapidly. Lorikeets do not practice gliding or soaring. Their flight style favors rapid takeoff, tight turns, and precise landings. These skills are essential in dense forest canopies where branches, leaves, and other birds fill the airspace. Mistakes lead to collisions or loss of access to food. Social dynamics shape learning. Juveniles experience frequent displacement at feeding sites. These moments teach speed and persistence. Rather than defending territory, young birds learn to exploit brief openings, darting in to feed and retreating before conflict escalates. Communication becomes more refined with age. Vocalizations shift from simple calls to complex sequences that convey location, urgency, and social status. Sound travels efficiently through forest environments, allowing birds to coordinate movement without visual contact. As individuals mature, they begin to integrate into larger flock structures. These flocks are not permanent units but fluid assemblies responding to resource distribution. Membership changes constantly. The lorikeet does not rely on long-term group stability. It relies on shared awareness. Breeding introduces selective calm. Adults reduce unnecessary movement, focusing on efficient foraging and nest defense. This contrast highlights behavioral flexibility. The same bird capable of chaotic flock dynamics can operate with precision and restraint when conditions demand it. Threats continue to accumulate as habitats change. Deforestation reduces native flowering trees, compressing food availability into smaller areas. This intensifies competition and increases energy expenditure. Urban expansion introduces hazards such as traffic, glass collisions, and disease transmission. Despite these pressures, lorikeets often appear abundant. Visibility and noise can mask underlying stress. High numbers in localized areas may reflect habitat compression rather than true population stability. When resources are forced into limited spaces, density increases artificially. Ecologically, lorikeets maintain a unique role. Their feeding behavior favors cross-pollination between distant trees. This promotes genetic diversity and resilience in plant populations. Loss of lorikeets would ripple outward, reducing reproductive success for many flowering species. The bird's evolutionary commitment to nectar limits its options. Unlike generalist parrots, lorikeets cannot easily switch diets. This specialization makes them efficient under stable conditions and vulnerable under disruption. Their success depends on the continuity of flowering cycles across landscapes. Yet the species does not resist change passively. Range expansion into new territories demonstrates exploratory behavior. When suitable plants appear, lorikeets arrive quickly. This responsiveness allows short-term success, even as long-term stability remains uncertain. The lorikeet's world is loud, fast, and saturated with color. These traits are not excess. They are adaptations to a life where resources appear briefly and competition never pauses. Silence and stillness offer no advantage here. The lorikeet's story does not resolve into calm. It never has. Its survival strategy is built on motion, noise, and immediacy. Where other species seek refuge in stability, the lorikeet thrives in flux. Flowers bloom and vanish. Forests change shape. Cities intrude. The bird responds not by retreating, but by accelerating its life. This acceleration defines its relationship with the environment. The lorikeet does not wait for ecosystems to settle into predictable patterns. It tracks change continuously, adjusting routes, timing, and social dynamics in response to shifting resources. This responsiveness gives it short-term resilience, but it also locks the species into a narrow dependency on flowering systems that must remain functional. Color, often mistaken for extravagance, becomes a tool in this environment. Bright plumage ensures instant recognition within crowded feeding sites. It reduces hesitation during encounters, clarifies species identity, and reinforces cohesion within chaotic flocks. What appears excessive is, in fact, efficient. Sound plays a similar role. Constant vocalization is not noise for its own sake. It is information exchange. Calls map food locations, signal agitation, and coordinate movement across complex spaces. Silence would isolate individuals. Sound keeps the system connected. The lorikeet's intelligence lies in integration rather than planning. It does not store food or prepare for distant futures. It reads immediate conditions with remarkable accuracy and reacts without delay. This makes it highly effective in environments where predictability is low but opportunity is frequent. However, this same strategy carries risk in a rapidly changing world. When flowering cycles break down, when native plants disappear, when urban food sources replace natural ones without nutritional balance, the lorikeet system begins to strain. Adaptation can mask stress for years before consequences appear. Conservation of lorikeets does not depend on isolating them from change, but on preserving the processes they rely on. Diverse native flora, staggered flowering cycles, landscapes that allow movement rather than confinement. The bird does not need protection from the world. It needs a world that continues to function dynamically. In ecosystems where these conditions remain, lorikeets flourish. They pollinate widely, maintain plant diversity, and energize forest canopies with movement and sound. Their presence signals productivity, not fragility. They are indicators of systems that still reward speed, memory, and coordination. The lorikeet will never become quiet. It will never slow down to accommodate observation. Its life unfolds in flashes, of color between leaves, of sound across branches, of motion through light. To see it clearly is to accept that some species are not built for stillness or symmetry. As long as flowers continue to bloom in sequence rather than silence, the lorikeet will remain. It will arrive loudly, feed briefly, argue fiercely, and move on. No territory claimed, no structure left behind, only pollen transferred, energy expended, and life advanced. In this restless cycle, the lorikeet embodies a truth of survival often overlooked. Sometimes endurance is not about holding ground, but about never standing still.